Okay, in this video we will discuss what is called in many books the hat problem. First I'll say the problem with the hats, and then I'll say how I like to view it. I think it's easier to imagine it. It's the same problem. The hat problem goes like this. There are 5 people in a room, each one with a different kind of hat, different color hat, let's say, and there's a fire alarm going off. Everybody grabs a hat and runs out as fast as possible. The question arises, what is the probability that no one should get the right hat? You just assume that nobody looks, nobody has time, just everybody grabs the first hat he sees. So without figuring out exactly, we can understand that it's a very small probability. We understand that maybe 2 of them will get the right hat, or 3, or maybe at least 1 of them will get the right hat, but that not even a single guy should get the right hat. It should be so awkward. That's quite far-fetched. That's just our intuition. We want to do that mathematically to get an exact answer. What is the probability? So this is the hat problem. Now first I want to change it into a chair problem from a hat problem, because you're going to see it's easier to imagine and to solve it. The chair problem goes like this. They are in the room, they have 5 chairs, and it says on each chair with a big magic marker on the seat, it says, it's written A, B, C, D, E. One chair has an A on it, the other one a B, then a C, D, E. Okay, now we have 5 people entering the room, and they have t-shirts. One has in his t-shirt a nice big black A, the other one a B, the other one a C, D, E. So we have 5 people here with nice t-shirts labeled A, B, C, D, E, and then we have 5 chairs. And we have the people sitting down on the chairs. So we'd like to know, it's the same idea basically, but you'll see when I make a diagram it'll be easier to imagine with the chairs. So people are sitting down, and we want to know, we'd like to know, okay, here I'll start to give the answer a little bit. How many ways can these people sit down in total? How many different ways can you sit them down? I'll explain soon what it means. And how many out of these ways are ways that are totally disordered, meaning to say that none of them gets the right seat. A sits on chair B, B sits on chair A, and so on and so forth. None of them matches the t-shirt with the chair. So this is the same idea, but here it's more tangible, and I'll show you on a paper, just so you should get the gist of what we're talking here. The first question is much easier, because that's just simple, a question of arranging the letters A, B, C, D, E, these 5 letters. How many ways can you arrange these letters? That's the total ways we can seat these people. I'll show you how this works. Okay, here you see I made chairs A, B, C, D, E. These are the 5 chairs. Now I'll take the side, we'll start enumerating all the ways people can sit on these chairs. A, B, C, D, E, C, B, D, A, E, E, C, D, C, A. I just randomly jotted down a few ways how to seat them. I'll make it close to the screen, everybody be able to see. Okay, you see, make it clearer. Okay, now it's clear. The first line has A, B, C, D. It means A sits down on chair A, B sits down on chair B, C sits down on chair C, D on chair D, and everybody gets his right chair. That could happen. The second way is C sits down on chair A, B sits on chair B, D sits on chair C, A sits on chair D, E sits on chair E. Here in this case we have two people that actually got their seat right. Mr. B and Mr. E, they both match, their t-shirts matches to the chair, to the ladder that's on the chair. The last case that might also happen is none of them match the chair. You see Mr. E sits down on A, C sits down on B, D on C, B on D, A on E. So bottom line is none of them got the right chair. Not even a single guy can look at his t-shirt and say, "Oh, look, my t-shirt matches the number on the chair, the letter on the chair." So some knowledge, just a little bit of probability combinations, we know first of all that how many ways can you write down. I just wrote down 3 ways. I listed the letters from A to E. I listed them 3 different ways. So somebody who learns a little bit of math, I think it's even the high school, knows that the way to figure out this, how many ways can you enumerate A, B, C, D, E in different orders, the answer is 5 factorial. That's 5 times 4 times 3 times 2 times 1. That is 120. 120 ways you can list them. If you would like to know how this formula is derived, please just look it up, and I will not explain it here. It's quite simple, but this is not what I would like to discuss now. So this is the simple formula of figuring out how many different ways you can write these letters from A to E, different orders. Our question is, however, out of these 120 orders, how many out of those are totally messed up? In this sense, I mean that none of them matches the chair. If even one of them finds his chair, we would not count that. We want to know, out of these 120, how many ways are messed up completely. That is the question. So finally, after talking 10 minutes, we know exactly what we're trying to seek. And that's going to be the probability, obviously, because the total ways is 120. Out of those, let's say there's 12 ways, or 13 or 14 ways, so it's 14 out of 120, the probability that none of them should match his seat. So I will start to explain an interesting way how to derive it. There's another way also, but I would say one of the ways how to derive it. And the way goes like this. First of all, we say like this. Let us start with a very small sample and we'll work ourselves up. We'll start off with exactly three chairs and 3 people. That will give us a small focus and we'll build ourselves up from that. So we'll start just with A, B and C. So just by simple enumerating, we know that there's only two ways that are successful. In this case, successful means messed up. Which 2 ways are successful? I'll write it down on the paper. C, A, B, and B, C, A. Close to the screen. C, A, B and B, C, A. These 2 ways, if you realize, not a single letter in its place. The A, from the first example, the C is not in its right place, the A is not in its right place, and the B is not in its right place. Second example, the B is not on its place, the C is not in its place, and the A. These 2 examples out of the 6, we know 3 factorial 6. So it's very simple. The answer would be 2 out of 6. So in this case, it's a third chance that everything should be messed up, because 2 out of the 6 ways are messed up ways. There's 6 ways you can arrange these letters. 2 out of the 6 are messed up. So we know halfway the answer, less than halfway, because we only know the answer for 3. And this we did by simply the hard way. It's called the brute force method. Just write it down and see how many ways are the messed up ways. But we will find an interesting technique how to build up from this, add another person, another chair, and then some clever way how to, if we know 3 we can know 4, if we know 4 we can know 5, and so on. We can work ourselves up to 100 or to 1,000. It takes a long time, because to know anything you need to know the one before. I'll explain it, and it will be very interesting to listen to this one. Let's now assume we'll go very slowly. One guy, Mr. D, walks in. Mr. D. He has on his t-shirt a nice letter D. And he brings in a chair also. It says D on the seat of the chair. It says a nice big letter D with a magic marker. He puts down the chair next to the first 3 chairs. But now he walks in the room and he sees how beautifully the first 3 people are seated in the messed up position, as I call it. That's the good position, the successful position, because in this case we're focusing on this, so this is the success. So he walks in the room, he sees, for example, the first way. He sees C, A and B. Now write a chair. You should understand that okay. Please look again at the top line. You'll see C, A, B. There's chair A chair B, chair C, and chair D. And we understand that C is sitting right now on chair A is sitting on chair B, B is sitting on chair C. Mr. D walks in the room. He brings a chair, he puts it down on the floor, and he is standing, and he's in a big trouble because he does not want to sit on his own chair. Why not? Because then he would make that one of the guys should sit on his chair, and that's going to be himself. So how does he make sure that this terrible thing does not happen? Mr. D is standing right now. He wants to kick somebody off his chair and make sure that everything is messed up again. So the next video I'll continue to explain what Mr. D is planning to do. And please bear with me, and you'll be very happy to listen to this one. Thank you, and just go to section 2. Thank you.